In this video, we're going to apply a /29 subnet mask to an IPv4 address and identify what happens to the size of the network. They've been getting smaller and smaller. We covered that in the last video. Let's take a look at what we have here. Subnet mask /29. That means the first 29 digits of the subnet mask. Count them. There's 29 ones in a row. Are all now set to 1, which means the first 29 digits of the address out of 32 are going to be set for the network. And we only have 3 digits left per host. Holy cow, this is going to be a much smaller network. And for the first time in all these videos, the 192.168.100.10 isn't going to be in the very first one. It's not going to be in the 0 subnet. It's going to be higher up than that. It'll be in the truly the second subnet, but we'll call it the 1 subnet, not the 0 subnet that it'll be posted in. So let's take a look at this. Once again, since we have 29 digits in the subnet mask that are turned to 1s, that means that our subnet mask value is going to be 255, 255, 255, 248. Where does 248 come from? That is 128 plus 64 plus 32 plus 16 plus 8. And all of those together are going to give you 248. 248. Now, if we look at our binary code in our address, that means that these digits here, everything that is red, needs to be exactly the same to be in the very same network. So, 192, direct match. 168, direct match. 100, direct match. 10, not a direct match, but the first 5 digits have to be exactly the same. So the first 5 digits have to start with 00001. And then after that, the last 3 digits can be anything that you want, but they have to start with 00001. So I'm going to go ahead and write those out in red as we've been doing. So the first part of this, the network part, has to start with 00001. Has to. And so that's where our first address will be, and our second address will be looking like this, or our broadcast address. We'll go back to our original pen color. And the lowest possible address that we can have left would look like this, which is going to equal, let's see, 8. 1, 2, 4, 8. Yes. And the highest possible address we can have in this particular network is going to be 8 plus 4 plus 2 plus 1. It's going to equal 15. And in this case, for the first time in all the videos, 192.168.100.10 is going to be in a network that doesn't have a network ID of 0. The network ID this time, we'll write it across the top. I'm so excited that it's not 0 this time. Network ID is going to equal 192.168.100.8. And our broadcast ID is going to be 192.168.100.15. And that's our new network. So network sizes are small. If we start looking at the different ranges of addresses that we can use with a /29, we'll have a network that's going to be in the 4th octet 0 through 7. We'll have another that's going to be 8 through 15, as we just saw. The next one will be 16 to 23, 24 through 31, 32 to 39, 40, and so on and so forth. And we're just going to keep adding, keep creating networks that are only 8 addresses big with a subnet mask of /29. Very, very common subnet mask if you're leasing addresses from your internet service provider, where maybe you have a couple of services that you want to use. They need public IP addresses, so you need 3 or 4 public IPs. They're going to give you a /29 because there's 8 total addresses, 6 of them are usable, and they're going to want to keep 1 to put them on the network. You'll have 5 more that you can utilize and have for yourself, okay? Next one, next stop, /30.